In this video, I'm going to walk you through Lesson 11 of Unit 8.1 from OpenSciEd. Okay, we're actually just entering the third lesson set, and the question to this lesson set is, what can we design to better protect objects in a collision? So we basically need to re-anchor, which means that we're going to go back to that anchoring phenomenon, we're going to revisit it, and we're going to establish the purpose of a phone case. So we're going to revisit the statistics that we saw in Lesson 1. You're going to read through them, and one thing you're going to really point out is that 27% of people said their phone was in a case when it broke right here. So this is going to navigate us into thinking about phone protection or cases that are on phones and then other things that also need protection as well. So really point out this fact right here that some phones even break when they're in a phone case. And so we're going to start by thinking about a list of criteria and constraints. Now, we're actually going into an engineering lesson, and you do not need to explicitly teach the engineering design process, but you do need to engage students in the steps of the engineering design process. I just want to point out real quick the steps of the engineering design process as shown in the framework for the Next Generation Science Standards. You can find a lot of different versions of this online, but this is just a 3-step big summary of the iterative process. And basically at middle school, they're going to define and attend to precision of criteria and constraints. And so we need to, develop ideas about criteria and constraints, what it needs to be successful and what's going to limit the solution, which would be the constraints. We need to develop solutions and then actually combine parts of different solutions to create a new solution. And then we're going to optimize a solution, which means we're going to use a systematic process like a decision matrix. We're going to test our designs and we're going to refine our solution. So this is the summary of basically the steps of the engineering design process that we're really going to focus on in the Next Generation Science Standards. So now that we've looked back and thought about phone damage and that we need to make a better phone case, we're going to create a list of criteria and constraints that a phone designer might consider if they were making a better phone case. And so a chart like this is going to be created in the material setup. You'll see the prep for this. Basically, this is all going to be pre-made. This is what's going to be filled out. You can do this under a DocCam if you want. So just print this out on a piece of paper or use a chart poster or even a whiteboard to do this. But you're going to come up with the purpose of the phone case. It's to protect our phones from damage. And then we're really going to develop the idea of what is criteria and what are constraints. So criteria are things an object needs to have been met to be successful, to meet the purpose of the device. Constraints are all other considerations that limit the building of this or from people from using it. So let's go through this a little bit. So criteria needs to be made out of good materials. It needs to be cushiony. Maybe we're not so sure if it needs to be thick. So put those question marks if people aren't quite sure. We're going to figure this out. For the constraints, it needs to look good. That's a constraint. It also could be a criteria, kind of how you look at it. But a constraint would be, it needs to be reusable. It cannot be a one and done. It needs to be small enough to fit in a pocket or in your hand. It needs to be cost effective. It can't be made out of gold. It's going to need to be made out of something that you can sell for cheap. And also some materials might not be available. So carbon fiber might not be something that we have availability to use. So we have some limits on our design. We also have some criteria that we need to make in order to make it be successful. So then we start thinking about other objects that also need protection. And here's a chart that you will fill out. The materials prep gives you, basically, you're going to make the T chart, all the orange is pre-done, and then you're going to fill out the black and red here. So you're going to get students to share ideas about things that they have that break that also need protection, like their laptop, their drink glasses, their eyeglasses, their heads when they're playing sports, a window, their elbows when they're playing sports. So what are all these things that can break, and we could make protection or protective devices to help protect them? So this is important that you do that chart, because then students are going to choose one of those objects that they're going to design a protective device for. So we think about and choose one, And here's a handout to just kind of get them thinking, what's the purpose of your protected device? This is what they're going to try to protect right here. What's the criteria? What's the constraints? So again, we're developing criteria and constraints. These are engineering ideas. You need to develop them just as you would science ideas. And then you're going to answer a few questions about the shape and the structure of your protective device. Then we're going to draft some ideas. Now, this could be considered a pre-assessment. At the end of this series of videos, I'm going to talk about the assessment opportunities in this unit. But engineering, it's kind of something you need to engage in order to assess. And so this would be considered a pre-assessment where they're going to draft some ideas. And basically, they're just going to design what it looks like here, and then a zoomed in piece of the protected device. Basically, we're modeling it. And this is going to really navigate us into thinking about what are cushiony materials or protective materials made of, and how do they protect the device? And so that's what this zoom in bubble is going to do. Then we're going to provide some feedback to one another. We're going to share our draft ideas with a partner, and there is a slide to support you. And so they're going to share their design with a partner. Each person, here's some protocols, is going to have 4 minutes to explain and design their design and receive some feedback. Here's the questions you're going to answer as you give feedback, and then you'll swap, and the other student will share their design and get feedback. And then students are going to engage in a gallery walk, and they're going to give and receive feedback. Now, there is supposed to be a day break right here, so you can assign this home learning and get feedback from home, and then they'll make some revisions. But you can absolutely do this directly into the next step if you are on block learning. So basically, they get feedback from a partner, and then they're going to make some revisions, and then we do a gallery walk. And so the gallery walk, you put your models on the table, and each design can only have 3 sticky notes. So it makes sure everybody gets some feedback. And then we discuss the similarities in the feedback that we all got, and we create a whole list of criteria and constraints. And this list is going to be for all of our designs. So we're going to use Good Shapes, and these are other people that also had that same idea. We use tally marks to show that their number of students had this feedback on their design. They use materials that minimize damage. It needs to look nice. So we're basically going through our feedback, looking at our designs, and creating a list of criteria and constraints for all of our designs. And then before we leave, we're going to write down some questions and brainstorm some ideas for investigations. This is going to push us and navigate us into the next lesson. There is a T-chart that you can make. It does suggest that you give sticky notes out again, and then everybody puts a question on a sticky note and they post it on this poster. This can easily be done in your notebook as well. So what do we need to figure out? Get some questions there, and then how can we investigate this? And this is going to lead us into investigating different types of materials that we can use to protect our devices. Okay, that's it for lesson 11. Let's talk about materials prep in the next video.